Welcome back to the course. Today we'll be going through and setting up a custom camera using some lerp or linear interpolation for movement, a simple UI, and getting some other general stuff out of the way so we can actually be ready to move on for the hitbox and hurtbox systems. First, we'll learn a little bit about HUD and how we can kind of create one of those using the UI specific nodes. So what we're going to do is we're going to go up to the new scene button, create a new scene. We're going to click on the green node for the first time. This is going to be the user interface nodes. And it'll give you a node called the control node or control type node. Now, a very quick thing to mention with this is you'll see when you have this node kind of as your root, you'll see this orange box. Now I'm going to move this and you'll see this purple kind of outline here. This purple outline is our display. So this is basically the entire size of our display. Now, you can kind of mess with this as much as you want to, but one habit to get into when you are creating control nodes or anything UI related, to make sure that it scales correctly with whatever screen size you want to use, and if you want to adjust the screen size in the future, make sure it scales correctly, you want to come up here to the presets for the anchor and offset values. You want to click on that, and in the bottom right corner here there is this full rect button. You click that, and it will expand to a full rect. That is what we want, because this anchors it to the corners of our viewport, which means when we actually change our viewport size, it will stick with that. Now, I'm going to rename this control node. I'm going to just call this the HUD. We've got HUD for the HUD. And then we're going to add another node to this. It's another special type of node, so we're going to hit Control A and add. And we are going to look for the margin container, which is what this one is. And it says down here in the description, margin container, a container that keeps a margin around its child controls. So what this is actually going to do, and once again, you'll see this orange box, we want it to be a full rect. We'll get into the habit of doing this, and I'm going to remind you to do this a lot because it's a mistake that I've made a lot myself, and it's a pain in the butt to fix. Yes, what this margin container will do is it will add a basically padding or a margin around the sides of our screen. Now, I'm not going to adjust this at all. I will kind of show that off when we actually get to adding to it, which will be very soon. So with that made, we're going to hit Control S and save. We're going to go save this in the scenes under a new folder that we're just going to simply name UI. Click save and we're done. Now, this is just going to be the container for all of the other custom nodes we plan on creating that will contain our HUD. There's a reason why I like to set it up like this, and you'll kind of see why. I like to create a modular HUD the same way I like to create a player, like a modular player or a modular enemy, where I have my handlers. Just a little bit different naming schemes for these. So we're going to go and add a new scene. And the next scene we're going to be setting up is another user interface scene. So it's going to be another control node. You'll kind of get used to the flow of this. This is going to be named the coin counter. And we're going to need to add a few more things to this. You'll see this is automatically a full rect. That's what we want. We're going to add so we're going to hit Control A and add. We're going to add a HBox container, which is another unique type of node that we haven't used yet. This one's kind of like the canvas layer, or not the canvas layer, it's kind of like the margin container, where it adds a kind of margin to things. So in this case, it's going to just kind of arrange things in a line going from left to right. So it's going to arrange them horizontally, which is what HBox stands for, horizontal box container. So we're going to click on horizontal box container or HBox container. We'll click create. Now add it. Now, once again, we're going to go full rect. We're going to keep doing this. Now I'm going to actually go and save this under the UI folder as coin counter. Now we need to add a couple of labels to this, because this is just going to be the label or the actual counter that is going to show how many coins we have. And we're just going to add two labels to it. And labels are basically a way of, well, at least they're a UI node that allows you to display plain text. And that's all we're going to need, is just some plain text on the screen. We're going to need to modify one of them as well. So we'll add a label. I'm going to press Control D and duplicate the label. Now I'm going to rename the first one coin text label. And then I'm going to rename the second one coin counter number. Now, I'm kind of being very specific with these, so it's a bit easier to understand what's going on. because what I would usually do is I would end up leaving the top one just as label, and then I'd rename the second one to just coin counter label. But this just makes it easier for you to kind of follow along. We're going to hit Control S and save. And then we're going to add a script to the coin counter here. Now I'm going to go and give this a class name as well. I'm going to call this, so class underscore name. And we are going to call this coin counter. Now we're going to be a bit more specific with this one. This is kind of how I like to do my UI kind of nodes. Is I'm going to put an underscore after this and just put UI after it. It just allows me to very easily see when I'm going through a list what my UI nodes are. We're going to need access to the ready function. So func underscore ready. I'm going to press pass or type pass. And then I'm going to create an onReady variable for the coin counter number. So the second label. Now I'm going to pause over, hold down Control, left click drop. Typecast it as a label. Hit Control S and save. And now what I'm going to do is go back into the 2D scene. We're going to add to these real quick. We're going to change the text. The coin text label, we are just going to want to just call coins with a little colon and a space after it, just so we can get some correct spacing. Now, the coin counter number, we're going to want to put what we would consider a good max number. In my case, I'm just going to do 999. Now, this number doesn't actually entirely matter. It just is kind of for looks. Now, don't worry about how the text looks for now. We're not going to worry about that. Now, with that done, we need to think about, if I go back to the script, we need to think about how we're going to be updating the coin counter number here. Now, if we remember back to when we originally set up our coin, we also set up another script, or specifically, we set up a manager called the collectible manager. Now, if I open up this script and go into here, we set this up. It's a variable that contains the current amount of coins we've collected, and this gets updated when this function gets called, which comes in from a signal, and this signal gets fired from a coin when it gets collected. So every time we collect a coin, this signal fires, it increases the amount of coins we've collected by whatever the amount or value that coin has, and then it stores it. Now what we're going to want to do is use the maximum amount of coins that we have, or the current amount of coins we have, and use that to update our label. And to do that, we can do something really easy. We can go to our autoloads, into our signal bus, and we can just create a new signal for this. So that's what we're going to do. We're going to go signal, and we'll call this on underscore coin underscore counter underscore updated, because that's what this is going to do. This is going to update our coin counter. It's going to need a value, which is going to be of type int, because we're going to need to kind of pass through the value of the amount of coins we have. And then we're going to do the same thing we've done here with the function and create a new function for it. So func emit underscore on underscore coin underscore counter underscore updated. It's going to need a value parameter, which is going to be of type int, and it will return void. And now, as we've done with this signal, we just need to call it. So we're going to need to emit that signal by just typing in on coin counter updated dot emit and pass through the value. And that's it. That is our signal setup. So we can kind of connect between our coin counter manager and our coin counter label. So all we've got to do is go back into our collectible manager, and in the function that gets called via a signal, we are now going to fire another signal so we can make sure our coin counter label or our coin counter UI gets updated as well. So we're just going to go signal bus dot emit on coin counter updated, and then we're just going to pass through the current coins collected, and we'll hit Control S and save. So now this is firing. We now need to go set up the listener. And the listener, of course, will be in the coin counter. And we can just connect that in the ready function. So we'll just do it again. We'll go signal bus dot on coin counter updated dot connect. And then we'll connect this to set underscore coin underscore counter underscore label. So this is going to set the label. I'm going to Control C and copy paste this so we make sure we don't mess up the function name. So this is going to need a value of type int, and it's going to have no return type, so void. And now we just have to do the simple thing of changing the coin counter number to reflect our current amount of coins we have. And to do that, all we have to do is call our coin counter number like so. And then we hit dot because we want to access the text inside of it. And we want to set that equal to the value. Now, a good habit to get into is when you are converting a integer or any other value or variable type into a string is to actually use a string conversion by using str, then your parentheses, and inside the parentheses you pass in your variable that you want to convert. So in this case, the value. So I'm going to hit Control S and save. I'm going to go back to the main menu here, or our main scene. Now I'm going to want to add, actually we'll go to the HUD and we'll add the, so we'll Control Shift A, we'll add the coin counter, so the coin counter, to the margin container. And you'll see now that this is a bit odd, right? This is dead center of our screen. We don't want it dead center of our screen. And this is kind of where you need to remember, or kind of how you want to set up your labels and your containers and things. So this is centered because this is full rect. What we're going to want here is top left. And that's going to push it up to the top left side of our screen. So I'm going to hit Control S and save. And this is for the HBox container. Make that very clear real quick. HBox container, anchor points, top left. Now I go back to the HUD and it's centered correctly. Now, one thing I don't like about this is that our text here is kind of pushed up directly into the corner. And that's where this margin container comes in. We can click on the margin container, come over to theme overrides, constants, and these are where you can set your margins. I usually tend to stick to a 12 pixel margin on all sides because it gives this kind of buffer about this width and this height on every side of the box here, or every side of our screen. So I can hit Control S and save, go back to the main menu. Now we're going to need to add a new node to the main menu, and that is going to be a UI container. And for a UI container, we're going to just want to add a canvas layer. That's a canvas group. We want a canvas layer. And this is another new node we haven't tested yet. This one just says a node used for independent rendering of objects within a 2D scene. So this is a really important node to use here because we're going to want our UI to render correctly on our screen, right? If we just throw our UI in there now, it will sit kind of where the screen is here. I'm going to close this. So this big purple box here is our screen. Our kind of coin number or coin value will sit right here, and it won't move. It won't follow the camera. It won't kind of follow the character. And, you know, we kind of want it to do that. We don't want it to just be a kind of static thing. So once again, Control A to add a canvas layer. I'm going to move the canvas layer above the level container, but below the manager container. I'm going to rename it to UI container. Then I'm going to hit Control Shift A to add, and I'm going to add the HUD into it. And you'll see now that the coins are sitting here. So we're going to hit Control S and save. I'm going to hit play and make sure that it's actually functioning. And other than this little guy freaking out because he doesn't know what to do, we now have a coin counter that moves. So let's go and push this guy off the ledge, and there you go. We picked up that one coin and it updated our label. We now have one coin. So let's go back. Let's look at this number here. So go down to our coin counter number label. We're going to change this text to 0. Now, this is one of the two ways of doing it. Doing it like this means you don't have a testing value, right? If you just put it as multiple 9s or multiple kind of whatevers, what you can do is go into the script, and then on ready, you can set the coin counter number dot text equal to str 0. So string conversion 0, and hit Control S and save. Now this string conversion isn't actually necessary here. I just like to get into the habit of doing it. So what this is going to do when I click play is it will immediately set our coins to 0. Then I jump over, go collect a coin, and we're good. We can now collect coins. So with that updating, and if we remember correctly, what we did was, or when we wanted to look at our game loop, our health isn't actually health. Our health is the amount of coins we have. If we lose all of our coins, then we die. If we collect enough coins, we can kind of pass on to the next level or upgrade our character and save coins, all that fun stuff. But this is kind of our health value setup, and we'll kind of go into that a little bit more as we move forward. But for now, there is one thing that I kind of really dislike about this box, specifically this really light pink box, and that is our camera, and that is currently hooked to our player. Now, if the player gets deleted, something odd will happen, and I'm going to show this by going into the player script. And then under physics process, you don't have to follow along with this, it's just me wanting to show something off. I'm going to write if input.isAction just pressed, isAction just pressed jump. If that is pressed, I'm just going to write Q3 and hit Control S and save, and that's it. What this will do is delete the character. And watch what happens when we delete our character, right? I'm going to move forward a bit, and then bam, our camera jumps. Because we also delete the camera when we do this. And we don't want to be deleting the camera and having it kind of reset to the viewport view. We want it to kind of linger, right? We're going to want our camera to either lock onto something else or focus or just not get destroyed. Now, to do that, we need to go and set up a custom camera. So what we're first going to do is delete the camera 2D from our player entity. So we don't need that anymore. Hit Control S and save. Go over to our main menu. I'm going to collapse the entity container and level container because that get in the way. We're going to add a new node, and this can be of type either node 2D or node, which is going to do a node 2D. This, of course, is going to be the camera container. Now, it's really important that we move this one above the entity container where our player is, because we're going to want to make sure that this can pick up the signal from our player. Now, what signal is that going to be? Well, let's figure out how we can kind of code up a camera first. So we're going to do a new scene, other node. We're going to want a camera 2D. I'm going to be naming this you can name this either main camera, player camera, or kind of give it like an important name like that. I'm just going to call it the player camera. Control S and save. I'm going to go back a path, so we're just in the scenes folder, add a new folder, and this is just going to be for camera. Now I can add a script, create that. Going to give it a class name of player camera. There we go. And now we're going to need to kind of think about how we want to connect our camera and our player. Well, I kind of dropped the hint of we're going to need a signal. We're going to need somehow a way of connecting them without kind of linking them together too heavily. And the way that I like to do this is by creating a variable for the player and then typecasting it as the player's class. But the player doesn't have a class. So let's very quickly go back over to the player entity, go to the very top here and give the player a class name finally. Because there's a lot of things that I'm going to want to kind of check when it comes to the player in the future. So we're going to want a class name anyway. So we're going to call this player entity. Hit Control S and save. There we go. We can now go back up to the player camera. Now we can typecast this variable as a player entity. Set it equal to null and be happy with that. Now there's two functions we're going to need access to immediately. We're going to need access to the ready function, which I'm going to write past it. And then we're going to need access to the underscore physics process function. I'm also going to write past in there. And now we need to figure out how we're going to link these, right? So we have the idea of using a signal. So let's just go create a signal. We'll go signal on underscore player underscore ready. And of course, the player is going to need to pass through itself. So we're going to just do player and then typecast this as a player entity. Hit Control S and save. Do the thing before where we create a new function for it. So emit underscore on. Going to need a variable for player or a parameter for player of type player entity. Not player camera entity. There we go. Then we typecast it as void. And then we emit the on player ready signal. And we pass through player. I apologize if I am going a little bit fast. Control S and save. I'll try and slow down a little bit. So with our signal set up and sorted, we can now go back into the player entity specifically. We can go under to the ready function here, and we can actually use the signal bus dot emit on player ready, and then just pass through self. Because when the player is ready, we're going to want it to emit this specific signal. Now, the player comes with a ready signal, but I want a more globalized version of this where some things can listen to it, because the camera in the future might not be the only thing that listens for this signal. Speaking of, let's go into our player camera, into our ready function, and connect the signal. So signal bus dot on underscore player ready dot connect. And we're going to connect this to, see, it's really easy for me to sit here and go, like I could tell you the good and bad of how you should name something like this, right? But it kind of is up to you. My personal preference with this is I like to name the connection function for this set underscore target. And that is because I'm not always going to want the camera to just focus purely on the player. I'm going to want it to focus on different things. And there's kind of a few different ways of going about that. But for now, we'll just call it set target. So I'll copy and paste the set target. I'll pass through player as a player entity for now. It will have a void return type. And then we're going to do a really simple thing. We're just going to go player equals player. Now, this is going to cause an issue, right? This is called shadowing. Right now, we are shadowing a variable that already exists. We're going player equals player. How does it know the difference between the parameter player and the variable player? As you can see, if I highlight this, it highlights all of them, so it doesn't. So to change this, we're going to change the set target to target, and then we're going to go player equals target. Now, there is going to be the odd condition where, and this is kind of redundant, but I like to make sure because I've run into this issue before, there's going to be the odd time where this function somehow gets called with a null target, and if it's null, everything will kind of freak out and break. So we're going to do very simply if target is equal to target, I can spell there, target is equal to null, return. This is a null check. This is basically just saying, if this doesn't equal anything or it equals null, just get me out of there, don't do anything else. And this is going to be one of the two null checks that we actually do in this. So we're setting the target, and this is coming in through a signal. We now need to actually have the kind of follow target code. So I'm going to show you a really quick way of doing this, which is just going func, and then we'll create the follow underscore target function. I'm going to pass in delta for future reference, and then give it a void return type. I'm now going to go and check if player is equal to null. If it is, return. This is a very specific check to do. Basically, what this is going to go is if the player equals null, i.e. the player gets queue-freed or doesn't exist anymore, don't do anything, which means we won't have the camera freak out. It will just snap into place and it will just stay in place. It won't move, it won't do anything else. That's really useful for us. So for now, if player equals null, return. And if it doesn't equal null, we're just going to go position, which is the camera's position. And we're going to want to set that equal to the player dot position. I'm going to hit Control S and save. I'm going to go into the physics process, and I'm going to call follow target, and then I'm going to pass through delta. Even though we're not using delta, I'm just going to pass it through. Do this. There we go. And now, with that sorted, we can go back into our main. We can go into our camera container, use Control-Shift-A to add. We can add the player camera. Hit Control S and save again. Now I'm going to hit play. There you go. We have the exact same camera setup already and done. It feels no different, and yet we're using an entirely custom created camera. But there's two issues that I have with this. The first one is it's too kind of tight, you know, it just feels like it's completely glued to the character. I don't like how that feels. Now I need to go back and make sure that we remove the camera from this, which we have. So to change how that feels, we're going to go into the player camera script, and we're going to be using what's known as linear interpolation. It basically goes from point A to point B, and then it finds a value kind of between that, and it moves towards that. It kind of gives this kind of camera drag feel to it. Now, there is a correct way and an incorrect way of doing this, and by technicality, using linear interpolation to do this isn't necessarily the correct way of doing this, but I like the feeling it gives. It gives a really comfortable, really smooth feeling. Now, to do this, all we need to do is set our position equal to LERP. LERP is the lerp function. So we're going to want to set it equal to lerp, and then we're going to want to kind of fill in the variables. And it says here, the lerp function takes a from, and then a to, and then a wait. So go from this to this by this. And to do that, we're going to first pass in the position, or the camera's position specifically, because that's where we want to go from. And then we're going to want to do the player position. So player.position. And then we're going to want to set a wait. Now, we can just kind of code an arbitrary number, which I'm going to do for now. This is a habit we will not get into. We will not be making magic numbers. These are a pain. So just to get rid of the error, I'm going to put 7 there. I'm going to come up to the very top, and I'm going to add an export variable. And this variable is going to be for the camera underscore move underscore speed. Camera move speed, let's just call it camera follow speed. That makes a little more sense and it's a little easier to understand. So camera follow speed, it's going to be a floating type, and we're going to set it equal to 0.0. Now I'm going to hit Control S and say, I'm going to come down. I'm going to change this 7 to camera follow speed. Hit Control S and save. Now I'm going to change the camera follow speed to that 7 number. I'm going to hit play, and we'll see something weird happens, right? It just freaks out. And that's because linear interpolation, the final value here, should be between 0.0 and 1. So 7 is massively too high. Now, if I did 0.7, you'll see it works, but we're still kind of stuck to the character. We're still kind of glued to it. So if I did 0.07, there you go. We now have this kind of really, really smooth movement. So what we can do here is to make it so we never go past the minimum and the maximum, is we can actually change this export variable into an export underscore range. And then we just pass in the numbers we want to use. So we'll go 0.0, and then we'll use 1.0. And then I'm going to change the equals here to nothing, and we'll just make sure it knows it is a floating value. That way we can adjust up to 1 and then down to 0, and we can never break it. Learning how to do export ranges like this and a few other types of export categories, extremely useful if you're working with people, because then you know there is no possible way they can accidentally break something without you kind of knowing you're setting in safeguards. So 0.7 feels pretty okay. Now, the other thing you can do is you can multiply the camera follow speed by delta. Control S and save, and you're going to see something kind of odd. It takes a very long time. That's because we're multiplying by the current frame rate. Assuming the current frame rate is 60, this is basically going to be multiplying it by 60. It's the whole thing. Math right now, not my strong suit. So to get this to kind of function correctly, we can change this from 0.0 to 10. Control S and save. We can change this to 7. This might be a little bit easier to understand. We get the same kind of feel, but we're now locked between 1 and 10. 1 and 10 might just be easy to understand for some people, so that's what I'm going to leave it as. That is all we need to do, other than one thing. I dislike the fact that the camera is currently dead center. It just feels like there is too much screen, like too much wasted camera down here, right? We want it to be pushed up and to the right a bit, I think. Now, you can do that by changing the offset, but if you change the offset, it's going to kind of freak out a little bit. So we're going to go and set our own custom offset with this. we're going to do an export var, and it's going to be of type vector2, and we're going to want to call this the camera underscore offset underscore vector. Set it to a vector2 type. And then we'll set it equal to vector2 dot 0. And now what we've got to do is come down here to the player dot position, and then we want to just go plus, so we're going to add the player position and the camera offset together. Now what this is going to kind of allow us to do is start changing where our camera is. So if I change this to the numbers that I kind of figured out that I like, which is -40, remember negative in the Y in Godot pushes things up, and then we're going to change this to +20 because plus in the X pushes it to the right. I'm going to hit play, and now our camera feels just a little bit better. We don't have as much wasted screen down here. We can go a little bit higher with this, say -50. And now it's starting to feel a bit more familiar with games like Mario, for instance. So now we can jump around. You can see every time I jump, the camera kind of falls up, or it pushes up, and then it slows down as it comes back down, and it kind of lags behind the character a little bit. That way it just feels a lot smoother. Now, we have our UI and our camera up and running. I have a little bit of homework for you. I want you to see if you can apply lerp, or linear interpolation, to our movement handlers to handle the movement function. I'll give you a couple of hints. You'll need a new exported variable called acceleration, which will be a floating number. And remember, lerp in order from left to right takes the variable you want to change, what you want to change it to, and then the speed you want to move it by. Now, with that said, that's all we have for today. I'm sorry if this little refactor video is a bit boring, but they are really important to get used to, and they're a really important thing to kind of learn how to do. It's a really good way of learning. And we now actually have everything set up for the next topic, which is hitboxes and hurtboxes, and that is going to be a lot of fun. So I hope you've had a good day and a great game dev journey, and I will see you in the next video.